of a review of some vocabulary. So I want to know in the chat, what is the name of this straight line in circle geometry? It's a special name. And I want to know what is the name of that line. Who knows it? Yes, I see the answers coming through. That is called a tangent. And next week, we are going to be talking a lot more about tangents and how they're involved in circle geometry. Okay, what about this line? What is this line called in circle geometry? Okay, that's good. That is indeed called the radius. I think if we just hit mute.
Answer the key.
Let's have a look here. Mute all. There we go. There we go. Okay, and then let's do one more. This is a little bit sneaky. Okay, I haven't actually told you this one before, but I'm just curious to know if anybody's seen it. What is that line called? And maybe someone can unmute them, or someone can put their hand up and answer this if they know what the name of that line is. Chord tangent. Nice guess, Nkosi. Nice guess, but no cigar. I haven't actually mentioned this one yet, but Tandeka, you are on the money. So this is called a secant. So this is a secant where it cuts the circle in two places, and then when it cuts it in one place, it's called a tangent. But it's much more common to worry about tangents than it is to worry about secants, but good to know in your vocabulary. Okay, then let's just do a little revision of the different theorems that we've covered so far. So this first one, I would love someone to come online and just explain to me how we use this theorem when we're solving questions, or this first little picture that I'm showing you. We spoke about this in lesson 1. Who would like to just give us some information about how we use this picture? Just pop your hand up if you're feeling like you can give us a little bit of feedback. Otherwise, pop it in the chat. What does this picture show us? So maybe I should drag it around a little bit. What is this picture telling us? Okay, let's go to Cynthia. Cynthia, what do you think this picture is telling us?
Afternoon, sir.
Hey.
Are you good?
Very good. How are you?
I'm okay. The picture is showing us that an isosceles triangle has two equal angles.
Yes.
And side.
Yes, and that this isosceles triangle is going to be made up of radii in a circle. So basically, you have these equal sides that are basically given to you by the radii. And when you have a triangle made up by radii, the two base angles will be equal. And this pops up a lot. So thank you so much, Cynthia. What about, before you go, if you're still there, Cynthia, what about this next one? What do you think this is telling us?
A right angle triangle always has a 90-degree angle, I think.
Okay, very close. So when you have a diameter in a circle and you subtend an angle at the circumference, or you make an angle at the circumference, it's always going to be 90. So watch as I move this. Can you see how it's always 90 as long as I have a diameter? But the moment I move this, let's see if I can move this off. The moment I move that triangle off the center, then the 90 degrees go away.
Yes.
Perfect. Thank you, Cynthia.
Thank you, sir.
And then if we go to lesson number number 2, this was, we call this, well, actually, I'd love someone to come on and maybe explain to us what's going on in this theorem. Umta, let's go to you.
Afternoon, sir. How are you?
Very good, Umta. How are you?
I'm good, thank you, sir.
Tell us what's going on.
Practically, what's happening in like this diagram that you've shown is that any angle subtended from a circumference to a circumference, or that has an arc below,
Yeah.
the angle at the center will always be 2 times the angle at the circumference.
Okay, absolutely. So when you have a common arc, in this case, it's the red one, the CD, if you make an angle at the center, it's going to be double the size of the angle that you make at the circumference. And so again, if you're new today, we did a whole lesson on this theorem. So I don't want you to feel like, oh my goodness, he's just throwing things at me. We're just doing a quick little review. And this theorem is actually also comes up a lot. But notice how, even if let's go to 50, it works as long as the shape is constant, you always get that relationship. Let's make it 116. Okay, almost there. And then in the last lesson, we did another theorem and we gave it a bit of a nickname. Can somebody tell me what the nickname was for this theorem and how we used it? Let's see if we can zoom in. Who is feeling like they can tell me the nickname, or you can tell me, Ayole and Faith and Sia said the butterfly theorem. And indeed, the butterfly theorem, we can see that we can make this one wing of the butterfly really, really small, and we can make the other one big, but it stays fixed at 48 degrees, and it's not even involved with the center at all. And the common arc is this red bit at the bottom. So angles on the same arc are equal. That's what Nkosi said, and you're quite right. You can see this, and that was the whole of the previous lesson. So what I've really been trying to do with you guys is give you a good visual intuition or visual picture of how these work. And so now it's time for some new things. So, well, not quite new. In the previous lesson, I spoke about what makes something a cyclic quadrilateral. And if you look at the pictures on the board, what makes a cyclic quad? This would be a cyclic quad, and this would be, and this would not be a cyclic quad, and this would not be a cyclic quad. I would love someone to tell me why this thing over here is not a cyclic quad. So the fourth one, why is that not a cyclic quad? Let's go to Ellington. Ellington, why is that not a cyclic quad?
Good morning, sir.
Hey, how's it going?
I'm good, sir. I'm good. The reason why this is not a cyclic quad is because all sides of the quadrilateral are not touching the circumference.
Yep. Which one is the badly behaved one?
That would be T, sir.
It would be T. T is the badly behaved one. If T could just get on the circumference, we would have a cyclic quad. But unfortunately, it's just a normal quadrilateral.
Yes, sir.
Okay. Fantastic. Thank you. That was brilliant. Okay, so let us look at something today. The focus of the lesson today is going to be on cyclic quad theorems. And so here is the first bit of new information, a bit of new content. So if we look at this, let me let the animation come to life. And let me drag my cyclic quad around this circle. And what I notice is that my points are very well behaved, okay? The points stay, the 4 points all anchor themselves on the circumference of a circle. So this is a cyclic quad. Now, you'll notice that even though some angles change, some things stay the same. So take a moment to look at that and maybe put in the chat, what do you notice about cyclic quads and their interior angles? Maybe put it in the chat. What do you notice? Maybe let's talk about green angles and red angles, because that's the color that we have. So Natia suggested 180. So 180 seems to be involved. Sakile has said the same. I think I agree with you. It feels to me, which two angles add up to 180? If we had to try and put it into words, would anybody like to unmute themselves or try and put it in the chat? How would you say this in words? Which angles add up to 180 is kind of what I'm looking for. Sakila has said opposite angles add up to 180. I'm almost there. I like opposite, but there's something else I want to know as well. Umta, what have you got to say about this?
Sir, isn't it that the opposite interior angles?
There's the magic word. So the magic word Umta said there was opposite angles, absolutely, but opposite interior angles. They're inside the quadrilateral. So that pair over there, and then this pair over here. And so opposite angles in a cyclic quad are supplementary or add up to 180. That is the fancy way of saying it. So that's our new fact about circles that we're going to include today, or sometimes we call it a theorem. And then there's one other one. Let's have a look at this. So we're going to just have a quick look at this one. Now, we know that the interior angles add up to 180. I want you to focus on the green angles here. And I want to show you, as I play with my circle and kind of move it around, I want to ask you, what do you notice about a cyclic quad, no matter how strange it looks? I'll make as many strange cyclic quads as I can. What do you observe in this little drawing? Who would like to share about that? Yeah, so Sino has said the green angles remain the same. Let me try and break it, see if I can break it. 78, 78, 121. Yeah, I think, Sino, I think you're right. So how would we describe this in words? If I wanted to say, what's this angle on the outside called? And Sia Tokoza has also said green angles remain the same. How would we describe this relationship? So yeah, Sino has said the exterior angle, so the one on the outside, I definitely agree, it's the exterior angle, is equal to the interior opposite angle. So if you jump from 71 into the quadrant or into the quadrilateral, and you jump across, that's called the interior opposite. So the exterior angle equals the interior opposite. Yeah, and so that is also true in cyclic quads. Okay, so that's the two new ideas. Can you give me a thumbs up if you feel like you understand the two basic ideas that I've just spoken about? And a thumbs down if you feel a bit like this man is talking whatever, but I'm not understanding. Okay, people, then it's time for us to put our knowledge to use. Let us do this. So here is question number 1. I want you to find me X, Y, and Z, and I want you to put those answers in the chat. Off we go, students of the room. No worries. Welcome, Levo. And thank you, Eric. I don't know if you're still in the room, but thanks for coming to visit us. And yeah, you're welcome to hang around if you, yeah. So let's have a look. Okay, so I see X's are flying in. And I think most people have noticed that an X, this is the exterior angle. And so this must be 100. What about Z and Y. Okay, so I see that Y is equal to 90. Would anybody like to explain why Y must be equal to 90? Give us a bit of a verbal description. I mean, I think I agree with you, but I just want to check why is Y 90? Who would like to give us a bit of an explanation there? Okay. Yeah. Umta, what do you think? How did you know why this is 90?
Oh, so because it is, if you add up all the answers that we have, plus the Z that I figure out that it's 80, if you add them up and then subtract it from 360, you would get your 90.
Okay, that is totally a legitimate way to do it. I was just thinking, aren't these angles opposite angles in a cyclic quad? And so doesn't Y plus 90 have to equal 180? That was the theorem that we were talking about.
Oh, yes, sir.
But you're right. Your way is completely right because we get the same answer, which is 90. And then I was just thinking that you could either get Z by going angles on a straight line. So Z is 80 like that. Or you could say opposite angles in a cyclic quad add up to 180. Which is that one over there. So I like what I'm seeing in the chats. I think that students have got the basics of this. So I'm going to move on to a question 2. I'll leave that one up on the board. But if you could have a go at this next question as well. So find me X and Y while, yeah. Some students might still be checking their answers, but can you find me X and Y for question 2? Yes. Okay, so I see X is coming in. Faith, would you be willing to explain your answers? Or Koketso, would you be willing to tell us what you did? I see answers from Nikozola, Cynthia. It's just helpful to know your thinking. I love to hear, because there's actually a couple of ways to get to the answer. But yeah, let's go to Faith.
Hi, sir.
Hey.
How are you, sir?
I'm very good. How are you, Faith?
Good, thank you. Sir, I first solved X.
Okay.
So, 180.
Okay.
G plus E will give you 180, right?
Yes. So you could get this one over here first.
Yes, sir. And then I said 180 minus 88 again to find out the other angle.
Okay, but isn't this, hold on, if we're going to figure out this one, shouldn't we then go 180 minus 88? Because these two together, so then let's do this together. Did you get, take away the 80 is 100, I get 92.
Yes.
Okay. And so then you use that 92 to work out what X was.
Yes, sir. Because the X plus angle 92 will give you 180.
Yeah. So I agree with you. And so X plus 92 is 180. So did you take away 92 from both sides and then you got 88?
8. Yes, sir.
Awesome. I agree with you. And for y?
Y. Oh, I said 180 minus 105.
180 minus 105. Now we must be careful because this 105 is the exterior angle. So what do you think y is going to be equal to?
I didn't look at that, sir. So y is going to be 105.
Exactly.
Yes, sir.
Perfect. So you could have done it another way. You could have found 75 and then done the pair, but you can just go straight to the answer of 105 because you can see there's a cyclic quad. So I'll just, to make sure everyone can see it, like here's the cyclic quad. And then this one on the outside is exterior angle, and then the y is the interior opposite. All right. Thank you. That was awesome. I love how many people in the class are getting involved. It's really nice. It feels like a good community. And so shout out to those students who are, to everyone, but particularly those who are sharing the answers. We really appreciate it. Okay, let us do. Yeah.
I'm sorry, Annie's asking, how would you write the reason for that?
Okay.
Question?
So like I said, I'm not focusing on reasons at this stage because it feels to me like it's too much information at once, but there are official reason names, which I'll share in the last lesson of the series. In this case, when you use the exterior angle, it's just exterior angle cyclic quad. So that's the official sort of reason that we use to sort of describe what we're doing. But I will give you a list of reasons at the end, as long as you know kind of what angle is the exterior angle and which one it's equal to. So like y is 105. Okay. So let us do, I want us to do I want you to find me A, B, C, D, X, and Y. So let's do 3 more questions before our break, and then we are due a break. I think we've worked hard. Let's see if you can do those. Question 1, 2, 3. So over to the students. I see Nati has put an answer in there, and Sakile. And Boipelo. Keep the answers coming. Nashin. Okay, so from looking in the chat, so A is going to be 180 minus 86, which gives you 94 for A. Because remember, these two have to add up to 180 together. So A should be 94. And B should be 75, because these two together add up to 180. So B will be 75 degrees. So just check your answers for a moment. If you didn't get that and you want to ask a question, you're welcome to raise your hand. And just check your answers there. So C should be 101 degrees because it's the exterior angle equals the interior opposite. What about D? D looks like it's paired up with this one over here. These guys are interior opposite angles. Yeah, Vivian, let's go to you.
Hello, sir.
Hey, Vivian, how are you?
I'm fine, and you?
Very good. What can I help you with?
Okay, for number 1.
Yeah.
Because to me, it's a rhombus.
Aha. Okay.
And the rule is to like opposite sides equal to each other. So it's kind of confusing when you say 180 minus 86.
Very good question, Vivian. So one of the things that we learn in circle geometry is that, like some of the properties are a bit different. So you mentioned the shape of rhombus. Now, one of the things that I remember about a rhombus is certain sides have to be equal. Do you remember what a rhombus, like what are the properties it takes to be a rhombus?
The lines, it has to be parallel to each other.
They do have to be parallel, but actually in a rhombus, all 4 sides have to be equal. So even though this is a quadrilateral, it's a 4-sided shape, it isn't actually a rhombus. So that's where I think maybe we had a bit of confusion there. It's definitely a 4-sided shape, but it's not a rhombus. And so I think it's more about understanding that what this is a cyclic quadrilateral. So if you look at the 4 points of this quadrilateral, can you see they all lie on the circumference? So for me, there's no other information. We know it's a 4-sided shape, which is a quad, but we don't really know anything else. But we do know it's a cyclic quad, or a quad that has all 4 points in the circle. And one of the things we know for sure is that opposite angles in a cyclic quad add up to 180. So I think, Vivian, it's just a matter of doing the learning and then having that property kind of ready to go. Does that help a little bit?
Yes, sir. But sorry, for number 2, would you use the rhombus rule because of
so again, the cyclic quad rule. Yeah, so again, in number 2, this isn't a rhombus because to have a rhombus, you'd have to have all 4 sides equal. But what I'm going to say is that 96 plus D is equal to 180. So, and again, I'm making that claim that opposite angles add up to 180. So now D is going to be 180 minus 96 because I've taken away 96 from both sides. So what would D be then?
104.
Yeah, exactly. So this one over here is going to be 104. So if we look, we can do the third one together as well. So if we think of cyclic quadrilaterals, the 2 main theorems that we're doing today are that opposite angles add up to 180 and that the exterior angle equals the interior opposite. And I just want to ask you about this angle 92. What type of angle is 92? I don't know when you joined us today, Vivian, but would you agree that this is the exterior angle of the cyclic quad? It's on the outside?
Yes, sir.
So if that is not on the outside, the interior opposite for me is going to go inside and across. Now, this is a little bit different. What do you think X is in this case?
So I think it's 92.
I agree with you. Because this is slightly different. Can you see the difference where the exterior angle equals the interior opposite? And that's a slightly different theorem that we're using. Okay. You are doing awesomely well. Thank you so much, Vivian, for your help. I'm going to go to Sia. for an answer for Y? What about question Y? Or question Y, letter Y. What did you get for Y, Sia?
Sir,
Yes.
I'm here to make the error on number 2.
Is there an error?
You wrote D as 104. Instead, it's 84, sir.
Ooh, Sia, you are on the money. Let's just check that. So if I had that as 84, this does add up to 180. If it didn't,
yes,
Sia, you are winning at life. Thank you so much for the intervention. And I'm sure many students saw that. So just to clarify, these two opposite angles add up to 180. Okay. Awesome. So while I've got you, Sia, what about Y? Oh, I think Sia's left the building. But what I'm hoping is that Y should be 116 because it's the exterior angle of this quad. It's just a different exterior angle. Okay, everyone, let's just do, before we have our break, let's just do a quick thumbs up, thumbs down check. Thumbs up if you're feeling like you're generally following. Thumbs down if you're like, oh my goodness, I see circles everywhere, but not in a good way. Okay. All right. So let us go and have a bit of a break. So, before I get to the challenge questions. So let us all stand up and turn on our cameras. And yeah, let's give our bodies a bit of a break. So turn on your camera. Let us see your faces. And we're going to start by just swinging our arms from side to side and just taking some nice deep breaths. Make sure you don't hit anyone.
Please join us in the stretch, guys.
Okay, and then let's do some circles, little circles to start with, small radii, and then bigger ones like you're, I don't know, making wind power to power your lights at home. Okay, and then
that would be nice.
It would be nice. Stretch it out. To the one side. Oh, that feels good. I can feel that hunching over from today melting away. And here's the other side. Okay, now we just need to do one more thing. We need a quick little heart rate boost. So you all know what's coming next. We're going to do a jumping jack. And so a jumping jack, I'm sure you've all done it. We're going to do 10 of them. And we're going to start in 3, 2, 1, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I feel alive. Just about.
Energized. Ready for the second half.
And if you've got a drink of water nearby like me, take a sip. I think we've earned it. And let's do a little challenge question or a little puzzle. So a 300-foot train is traveling 300 foot per minute and must travel through a 300-foot long tunnel. How long will it take for the train to travel through the tunnel? So if you need to draw a picture, just take a moment. This isn't like this. This is not for anything other than the pleasure of being confused. But to see if you can put it on riddle. Yeah, you know, everyone likes to be. It's like a magician. Everyone likes to be confused. So I see a lot of people are saying 1 minute. So I'm not a very good artist, but whatever. There's my tunnel. This is going to be embarrassing. What does the train look like? Okay, my train's got lots of wheels on it. It looks more like a lorry, but anyway. So this is 300 foot long. And the tunnel is also 300 foot So this whole thing is 300 foot, and the train is traveling at 300 feet per minute. How long will it take for the train to travel through the tunnel? Well, when it starts, it's going to take a minute to get to the end for the front of the train, and then it's going to take another minute for the back of the train to get to the end of the tunnel. So the answer is 2 minutes, because it takes a minute for the front of the train to get through, but a train is only through the tunnel when the whole train has gone through. And Kosi has been surprised.
No, that was a good one.
It was, because you kind of think, okay, cool, the front of the train gets through the tunnel, but then the rest of the train must still get through.
Yes.
And the train's long. Yes. Okay. Oh, yes. Juliet, Siatokoza, everyone, they like that one. Chum is like, I know. I like the emoticons. They are awesome.
Loving these emojis.
Yo. Okay, yeah, that maths got it real. Okay, let us go back to the land of circles. Now, I know no one thinks about the back. You're quite right. So I'm going to take it up a little bit on question 4, because you guys have done so well in the first part that I feel like I just want to extend you a little bit more. So I want you to think about, what is the value of D in this question? So before you worry about C, so we're doing question 4, and you're given this drawing, and I want you to find me the value of D. So D is, what is the value of D? And maybe we can get some tips. If anybody has some ideas, they can put it in the chat or let us know. So this is definitely a slightly harder question, but we need to ask ourselves, what do we have for sure? Like, what do we know in fact, let me ask you that. What do we know we have in this question? What's the one piece of information that could be helpful?
Any ideas, guys?
If you think about what we've been learning about, so it could add up to 360. Yep. So I like that. It's a quadrilateral, definitely. But now, if I want to worry about D, what do you think? So D is opposite 3D. So that I like that, but there's something else about this quadrilateral. What is this? It looks a bit like it's squashed into one corner of the circle, but there's something else that's really, really important. I want someone to name it. But we can't actually, until we know this thing is around, none of our working out will really be helpful. We have to see this one thing. So it's not a diameter. Nice guess, though. If it was a diameter, there would be a center point, but it looks to me like it's squeezed in. So if we focus on this and this and this and this, these are what we call the vertices of the quadrilateral. Yes, Ellington, that is the magic word I was looking for. Very good. This, even though it looks like a very strange cyclic quad, it is indeed a cyclic quad. So you know that these are a pair of interior opposites. So what does that mean about D plus 3D? That could be helpful. So Anita, I think and Faith also, yeah. Faith, let's go to you.
Sir?
Yes.
I don't have a definite answer, but I think I know how we can solve this.
Okay.
180. So it's going to be 180 divided by 4.
Divided by 4?
Yes. Whatever answer you get, a third of it will be 3D, and Yes,
Ooh,
and then the other, yes, the other one will be D.
Can you tell me about this 4? How did you get the 4? That's what I'm most interested in, because I agree with you, but how did you get the 4?
You see, it's 3D, sir. Ne?
Yeah.
So there's an invisible 1 in front of the other D.
Yes.
So I just added
3D
it.
plus 1D.
Yes, sir. So I divided it by the 4, because it gives the 4. Yes.
So you said 3D plus 1D is 180. Therefore, 4D is 180. Therefore, divide both sides by 4 and you get 45.
5. Yes.
And then that makes 3D is going to be 135. Yes. Love it. I think you have unlocked the mystery. Okay. So based on what we've just been told, I want to know now, what is the value of C? So there's no more mysteries. We know D is 45, 3D is 135. I want to know what C is. Okay. So I'm seeing in the chat quite a few 60s. And I think what you guys are doing is you're saying, I've seen this trick before. 2C plus C must be 180, because these are also opposite angles in a cyclic quad. Therefore, 3C is 180. Therefore, C is 60, because 180 divided by 3 is that. Awesome, 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 awesome. I really, you guys are doing incredibly well. I'll just give you a moment or two just to take a screenshot if you want, because in a moment I'm going to zoom out again and see the remaining questions, and then we're almost done for today. We've done really well. We've covered a lot. Okay, 3, 2, 1, and off we go. Okay, so last question for today is question number 5. Okay, sorry, it's a bit big, but I think it's better if it's big for you to see, even if it's pixelated. So last question for today. Here is angle H sitting down here. And I'm going to point out that there are 2 little markings on this triangle. Find me angle H for this drawing. Find me angle H for this particular circle, which has a quadrilateral inside it with an exterior angle. Okay. So I'm going to give it a second for everyone to think, and then I'll come to you now. And then Lebo, if you could just get the quiz link ready, we're almost at that time of the day. Let's go to you.
Sir, may I please ask, does the exterior angle thingy count?
Does it count?
The exterior angle equals to the opposite angle. Does it count?
Okay. Yes. So this one is that, and I think this is the interior opposite. That's my hint. Let's see what else you can do. Mbali and Zanele, let's go to you. What do you think the answer is going to be?
I think the answer will be 53.
Okay. Speak me through or talk me through your process.
Okay. I said angle C is 106 degrees is equals to A. So and then A is equals to D, and then I divided D with 2 and I got 53.
Okay. I agree with you so much on the first bit, but there's one part that we're not using. So we actually have to use this triangle And what do you notice about this triangle? If you look at this triangle, what type of triangle is it?
An isosceles.
Yes. So what this isosceles triangle is telling me is that the base angle, so this angle over here and this angle over here, must both be the same. Can you see that? So what do you think H is going to be equal to now, using that new idea? I'll help you a little bit.
Okay.
So if you go 180 minus 100, oh, wait, minus 106, what do we get?
74.
Okay, so 74. So we've only got 74 degrees left to share, and we've only used up one angle. So we've got to share the 74 between this one and this one. So how do you think we're going to find H?
We'll divide by 2 and we'll get 37 degrees.
Yep, let me just make sure that's, yep, 37 degrees. And so H is going to be 37. So well done. That was awesome, awesome, awesome. And that was a hard question, hey? Because you had to use the original exterior angle theorem, and you had to use the fact that you had an isosceles triangle. And so the final answer will indeed be 37. Okay, everyone, it's been a wonderful session. So we are going to call it a night for tonight.